thank you. My name is indeed Hans Bos, and I've been working with Microsoft in the Netherlands now for the last 10 years. And I'll be doing this presentation, and it's going to be partly a presentation and partly, hopefully, a demo. And I'm going to do that together with my colleague Astrid Hakkenberg, who is sitting in front here, so she'll join me later on the stage. A little bit of background: the technology officer in the Netherlands, it's kind of like an ambassador between Microsoft and our Dutch partners and the Dutch customers and the Dutch government, for example. And as an ambassador, the idea is that you introduce all kinds of new technologies, innovations, have a conversation about the potential, have a conversation about the disruptive potential, what it could mean for industries, etc. So my background starts in 1995, almost 90, maybe a little bit earlier, when I was a software developer. And to give you a little bit, to feel my pain, if you will, to share a little bit of my pain, in 1995, I was asked by my manager to evaluate something that in those days was introduced as something that was called the Internet. And they said, here's a floppy disk. It's a 3.5-inch, you remember those? 3.5-inch hard floppy disks, high density. It was a floppy disk, and it had the Internet on it, or at least that was what the label called it. And the manager said, here, Hans, will you kindly evaluate if this could be something, if it could develop into something, what it could mean for our company, etc. It was 1995. And basically, I completely forgot to do that. So you would argue that's not a smart thing to do, is it? So a couple of years later, in 2011, somebody came up and said, Hans, there's going to be a presentation, there's going to be an opportunity, and the thing is, it's going to be at the Royal Mint in the Netherlands, where they where they make all the coins, the physical coins, right? It's going to be over there, and we need somebody to explain to the audience what the potential, what the future developments are going to be with digital currencies, or more popularly, cryptocurrencies. So I was thinking, oh, I'm going to do that very easy, right? Digital currencies, I'm going to evaluate a little bit. 2011, I ran into the Bitcoin, so I bought one Bitcoin for myself, and I did the talk, etc. And I completely forgot about the Bitcoin I had in 2011. Does anybody know the current value of the Bitcoin? It's not a good story, I think, is it? So let's a little bit of background. So now, as a technology officer, I'm doing a lot of talks recently about the disruptive potential, the context, if you will, of the blockchain. And just before I was being interviewed, somebody said, okay, what is the major change? If you look back, what is the major change since, for example, 2011 up till now? So 5 years later, what's the major development or major change on Bitcoin and blockchain, for example? And my argument would be, or my point would be, that it has completely flipped. Initially, the whole conversation was about the disruptive potential of the Bitcoin, and Bitcoin received all the attention. And by the way, you were very lucky if somebody asked what is the technology behind the Bitcoin and somebody understood something about the blockchain. In those days, it was all about Bitcoin, and maybe a few people understood about the blockchain. Now, it's completely flipped. Everybody's talking about the blockchain and using only the Bitcoin as one of the examples of possible use cases of the blockchain. So I would argue that over the past 5 years, maybe the major change is indeed that the whole conversation has flipped around from Bitcoin to the blockchain. And maybe not to everybody, blockchain or Bitcoin means the same thing. So we had this very interesting, although slightly difficult to understand and hear, presentation by Dr. Gavin Wood. And I looked him up on YouTube, for example, and there's a brilliant introductory video on Ethereum, what it means, how it was developed, why it was designed, etc. And it has, towards the end of this video, it's on YouTube, it's called Ethereum for Dummies. And towards the end, almost at the 20-minute frame, Gavin explains what is he trying to do with Ethereum. And I love the quote. Basically, he's saying, I'm not sure. It's basically up to you. If you want to adopt Ethereum, you develop something that fits your questions, that fits your market, that addresses your needs. And the only thing that we were doing is attempting to be useful and inclusive, and that's probably a reasonably good way to think about it. I love that quote. Maybe that's also symbolic, if you will, for the state of most conversations, most pilots, most proof of concepts, most hackathons regarding the blockchains. Maybe we're not sure yet what it's going to be. If it's really going to be as disruptive as many people promise us it's going to be. but at least we're all trying to achieve something that you could argue is maybe runs into something useful or becomes something useful, and at least hopefully most of our pilots and projects will attempt to be as inclusive as possible. Anyway, I was thinking of sharing a little bit of the context behind what we think, or what I think the blockchain means, or how the blockchain came to be. And initially, I thought about ledgers, smart ledgers, distributed ledgers. What is a ledger? And basically, humankind, mankind, society, the economy, we've been creating ledgers for thousands of years, right? And maybe towards the left, not the most flexible, not the most distributed, maybe not even the most secure ledger. One of the earliest ledgers was hammered onto clay tablets, basically. And this is an example of a ledger documenting stock for a farmer, for example. How many cattle does this individual farmer has? So it's a ledger, for example, in 4,000 years ago on a clay tablet. In the middle are ledgers from the last century, ledgers being taken down with pen and paper, stored as securely as possible in a closet, for example, at the grocery shop, wherever. And more recently, of course, in the last decades, we've been using ledgers, electronic ledgers, digital ledgers, like, for example, our host of today has created at Exact. So we have significantly developed, if you will, we've significantly improved on the quality, on the potential, on the usability of ledgers, if you will. But there's a long history, and we're still developing. We're still coming up with new ideas of the potential uses of ledgers, where they are creating value, how we could implement them, etc. Another thing that is consistently work in process are the shapes and forms of organizations. How we create value as a community together, how we organize ourselves around or in an organization, such as, for example, Microsoft. How do we organize ourselves into an organization? How do we organize organizations? So how do we cross the boundary of organizations, for example? It's a continuous process or a continuous work and development of how we think on collaboration between these organizations and how we think of connecting processes between these organizations, for example. And this also creates a lot of conversations, of course, about trust and connectivity, and indeed about distribution of data, for example. But organizational collaboration is a process continuously in development. And another domain, which we contributed to largely ourselves, is the complete digitization of society and the economy. This is an example. This is really an exponential curve, right? This is really an exponential curve in the volume, the quantity of data, incoming internet traffic at the Amsterdam Internet Exchange. In a time frame of 10 years, we went from 690, so almost 700 terabytes of incoming internet traffic in Amsterdam, to over 1 million terabytes of the incoming data in a time frame of 10 years. So this is a significant example, significant proof, if you will, of the enormous digitization of society and the economy. And it's all of us doing this, right? It's personal data, it's business data, it's open data, it's classified data, it's personal data, it's intellectual property data, it's all kinds of data. And it's an immense volume, of course, of digital value, if you will. And a subset of that digital data are, in fact, transactions. And transactions are taking place in processes. Transactions are taking place between companies, for example. Transactions are taking place by the second, by the millisecond, by the day, etc. And there's a huge growth, of course, also in the volume of transactions, in the value of transactions, in the complexity of processes and organizations behind those transactions. So these are just three examples of, for example, high volume transactions at Nasdaq, the American stock exchange, 25 billion messages on an active day. That's over 1 million transactions per second on a business day during working hours on the stock exchange. There's a large volume of transactions, of course. You may remember that a couple of years ago in the Netherlands, for example, we had this big incident with DigiNotar. Do you remember that? It was a significant security incident, right? And a lot of those transactions, a lot of the valuable transactions were digitally signed with a digital certificate. And if you can no longer trust the provider of that digital certificate, you can no longer trust the provider or the process behind that transaction, right? So in those days, when we were having this huge incident, when we were discussing solutions, when we were discussing the problems, at some point, and this was a brilliant moment, I thought, in Dutch news media, the minister who was responsible for resolving the incident and the issue was on television, and the minister was asked, "Dear Minister, is this going to be a huge economic problem? Is this going to be a huge societal problem if we can no longer trust digital transactions?" And this literally happened. The minister responded and said, "No, of course not. We can always go back to pen and paper." Right. This in the context of 25 billion messages at a stock exchange, 7 million containers annually being shipped through the harbor, the port of Rotterdam, more than 20,000 houses sold per month in the Netherlands. Those are all simple examples of digital transactions. This is a huge volume, a quantity in transactions. So combined with the ledgers, for example, combined with all these changes in organizational collaboration, with all these changes and developments in inter-company processes, with all the changes in digital trust, digital identities, etc., I would argue there is basically only one way forward, and that is keep developing this digital framework, this digital context. There is no way back. Definitely not back to the clay tablets. Anyway. Right? So we need to move forward. And that is why I think the significant attention, also from the media, from technology officers, from politicians, from civil servants, from business development managers, from innovation leaders, etc. This is probably why there is such a significant attention for the blockchain. The possible value, the possible contribution that the blockchain can bring in resolving all these issues behind the quantity of transactions, the trust issues, the internet as an infrastructure, etc. Up to, for example, that their own CTO, Azzure CTO, Mark Risanovic, mentioned that we expect that every industry, every vertical industry like pharmacy, media, financial services industry, etc., probably every industry is going to develop at least one, maybe even more, consortia to share indeed this blockchain infrastructure to build this trusted transactional environment. Now, you've been here already for a significant part of this afternoon, right? You've seen a couple of in-depth, behind-the-curtain kind of demonstrations, explanations of using blockchain technology. So maybe the next slide is kind of like wasted on this audience. But as we're also streamed onto the internet, I thought I'll explain a little bit about the background, the context of the blockchain itself. So basically, if you're not familiar with the blockchain, the summary is it's a secure, shared, distributed ledger. Very simple, right? We're all familiar with that. Are we? Any questions on this slide? We're okay, right? Okay. The next one, we're probably also okay on, right? One of the use cases, one of the best scenarios to discuss with politicians, for example, to discuss with government, to discuss with the potentially disrupted industries, is to explain that many processes, many organizations only exist because other organizations do not trust each other. A significant number of organizations were created currently and created in the past because, for example, organization A, who wants to deal with organization B, actually doesn't really trust organization B. But they have a dependency, or they do want to create some value, or they do want to participate in a value or supply chain. So what they do is they create a man in the middle, an organization in the middle. And they say, okay, this organization I do trust for certain reasons, certain arguments, etc. So a lot of existing processes, a lot of existing organizations in current markets and current industries were created because there was no trust between parties in a chain. Now, what happens if you can create, if you can develop, if you can program trust into an algorithm? You basically lose the business case, you basically lose the argument to create an organization or a man-in-the-middle model. And this is indeed maybe oversimplified, maybe at the PowerPoint level, but this is possibly the most disruptive situation or the most disruptive point of view or argument behind what the value is going to be of blockchain. It is possibly, it's likely, it's potentially disrupting a lot of organizations who are currently being built or are currently created because of a lack of trust between other parties or other people or other organizations. So we decentralize data, we decentralize the infrastructure in a context where essentially trust is now being installed or developed into the algorithm. Mathematically proven, cryptographically secured, etc., of course. Now, this has been ongoing for a while, of course. In 2011, when I was having this Bitcoin presentation, for example, I was definitely not the first, not the only person aware of this development, definitely not. It has been going on for a while. We call the Bitcoin kind of model, the Bitcoin development, maybe blockchain 1.0, the first version, if you will, the first instantiation of what blockchain could mean. Simply, Bitcoin. Ever since, we've been progressing, reanalyzing, thinking about it, developing further, and now we're maybe at the stage that we could call the blockchain 2.0, the kind of like the Ethereum, the smart contract era, where we're using the blockchain as an infrastructure, including some, for example, oversimplifying again, including some payload, for example, on the blockchain, and basically you can create something that's called smart contracts or crypto contracts or whatever you want to call it. That's the 2.0 version. Now, if you want to create value to a number of industries, if you really want to support business use cases in the market, then maybe smart contracts are not going to be the isolated smart contracts that are usually implemented in demos. The majority of real-world use cases are probably going to be built on top of smart contracts that connect with value, data, transactionals, code, for example, that are going to interact with value that is off-chain, stored off-chain, accessed off the chain, not stored in the blockchain or on the blockchain itself. And this is where we think blockchain 3.0 comes in, the next development, because currently in 2.0 models, you can, of course, use smart contracts and connect to an outside source for data, for code, for services, etc. They often use examples, LIBOR, interest rate exchanges, for example. You can, of course, connect to an outside source, but then it is introduced in what is called an oracle. Somebody says something, it's probably true, I'm not sure. It's an oracle, right? You're not sure if it can be trusted, what the oracle is saying. You have no context regarding the oracle. So it's of value, of course, but in a smart contracts or in a blockchain 2.0 world. Now, what if you can develop an oracle that basically becomes part of the trusted context, the trusted container, the trusted environment, the trusted process of your blockchain? Then you develop something that we started to call at Microsoft cryptlets. And that is what we think is going to be part of blockchain 3.0, the next iteration, the next innovation, the next development of the blockchain. So blockchain 1.0 in our minds is kind of like the Bitcoin. Blockchain 2.0 is kind of like smart contracts, maybe even including oracles. But the blockchain 3.0 is going to be about the blockchain plus cryptlets. That basically data or services that are stored or managed or processed off-chain do become part of your trust environment within the blockchain itself. Now, how does that look like in PowerPoint? Maybe something a little bit like this. So at the bottom, you see the infrastructure, which Microsoft calls a technical infrastructure called Microsoft Azzure. Microsoft Azzure is a global scale, hyperscale cloud infrastructure. It's a technical infrastructure. On top of that Azure infrastructure, we develop, or your partner could develop, or Ethereum has developed, for example, virtual machines, leveraging blockchain infrastructure and technology. Now, we are developing that the cryptlets are slowly becoming kind of like middleware services on top of that blockchain infrastructure. Now, and once you have that blockchain infrastructure plus the cryptlets, plus the smart contract model, then we think you start to develop real industry, business models, templates, etc. Now, this is where we think Microsoft Azure comes in, and this is also why we call it blockchain as a service. Because the infrastructure is already there, we use resource templates for you to have a very rapid development, a rapid start into this, and the end result is going to be something that is of real value to the market and real value to the industry. Now, this is a short introduction into what I think is blockchain as a service, and I'm going to ask my colleague Astrid on stage to do a live demo of what it actually looks like if you do deploy blockchain as a service on top of Azure.
Thank you.
Was that a good introduction for you?
Very good, thank
Helpful.
you.
Good.
So, yeah, let me start to change this. So you can actually see my screen, I hope. Yes, you can. Okay, good. So what I just wanted to show you is how you can actually use all this. So blockchain as a service, what do we have currently? It means at this moment that you can easily, using a template, set up a complete network environment running Ethereum. So that's basically what you get. So you will get an environment consisting of several transaction nodes that are accessible from the outside world, and you can have different sets of mining nodes representing the different parties in a consortium. And these can be on Azure, these can be off Azure, these can be in the same data center, in different data centers. That's up to you, basically, how you would configure this. So I have this setup, which means that at this point, if we would look in the Azure portal, you would be able to see that I have a network here. So that's up here. And, well, you can see that it consists of a lot of different resources in the cloud. A couple of virtual machines where already, after you've run this template, Ethereum is set up. They know how to talk to each other. They know how to talk to the transaction nodes. There is an administration page that you can actually use to just see that your network is really actually there. And of course, you can also monitor all of this within the portal. And as you can see, I actually have a network here. It's running some nodes. It's doing some transactional processing. And just to get started, if you would look this up, you would see there's a tutorial that will actually show you, after you've set this up, you can use MetaMask, which was mentioned before, for example, to actually just simply exchange Ether between different accounts, and no programming involved there. It's just the whole infrastructure and the network available. So what else do we have? Because this is what you need to run something. If you look at tooling, what you're looking at now is Visual Studio Code. It's just a code editor. And what we do here is we do support the Solidity programming language, also already mentioned today. So that means that if you start building a contract here, you get IntelliSense. You can compile this easily from within this editor. It's just a simple and easy way to actually start writing your contracts. And after you've compiled this, you will get what you need to actually run this contract. So you will get the ABI, the interface that you need to actually access a contract. And also, of course, you get the compiled code that you also need to deploy an instance of this contract to the blockchain. I already did this. I already deployed this. And what I did is I wrote a small client, or actually application, that in this case runs within my Outlook environment. And as soon as I go and write a new email, you can see that what I can do is I could actually say, OK, I would like to register this message on the blockchain. So where do I register it? Well, there is some configuration. So you can actually see that this is going out to Azure. I know you cannot read it, but it's there. And it's actually stating which account do I use, which, of course, you could integrate in different ways, and which contract, which instance of the contract am I going to use. So let's say that I would write an email to myself in this case. So we can actually see it. And give it some subject. And I could give it some content. And due to time, I just write a very simple email. If I send this, I actually made it send to my demo folder, so we can actually find it back. But if I send this, it will send the email, and basically here we can see what it did. So it used my email in this case as an attachment. So it completely hashed my email that I sent. And then it put the hash, including information, who sent this and to who was this sent, and a timestamp on the chain. And all of that is what you can find in this, sorry, where's my contract? In this contract. So basically, what I did is in here. So you can see here that what I actually do is I get a hash, I get the information from the email, I put it in. So this also means that if I take that hash that is now in my email, and I get a reference to the contract, I can find back the information, who sent this, to whom, and when was this done. And that means that on a later stage, I can rehash, of course, this email and check whether or not this is valid. This is just a sample to show you that when you start thinking about this, there are a lot of different things you could do using blockchain. And the way I built this is I did use the APIs that were mentioned before, but in my case, I didn't use Node. I used .NET, in fact C#, and I used a library which is called Netherium, and that's just simply a wrapper library around all the APIs that you heard about before, and that actually can do the Web3 and all the other things, and just make it very easy to call a smart contract or find information about transactions on the chain. So I guess we're out of time. So I will finish here. If you are want to know more or want to see more how this is done, just come to me, talk to me, and I'll give it back to you then.
No, just one comment. I know you're all very eager and enthusiastic now to start developing yourselves. So you go to azure.microsoft.com. There you can start a free trial account, for example. And then you go to portal.azure.com, and there you can get the dashboard and the management interface. You click on the plus, and you create automatically, within 20 minutes, a complete Ethereum, for example, consortium. Good luck. Thank you.
Thank you so much, Hans, and also the lovely demo. I mean, demos are the coolest things because now we can actually see it working, and I think it's really impressive to see what you've already done. I think this can potentially solve a huge problem we see in legal issues concerning the registration of emails. We are very short on time, so let's throw in one question.
You're literally throwing in questions.
Yeah, absolutely.
Is it working? Yes. When can we start using the cryptlets? Because you have to implement them in the Ethereum virtual machine. So I was wondering if you could give us a clue when we could start using them.
I don't think that is known yet.
No, but send me an email.
It's not public information yet when that will be available.
Yeah. But send us an email that you're interested and we'll keep you informed.
Yeah.
Okay, thank you.
That's okay.
Thank you. Thanks so much.